Hello my dear wonderful genius students, I welcome all of you to this YouTube channel. This is lecture number 23 on complex analysis, and in this video I am going to solve some additional problems by using Taylor's theorem. So without wasting time, let's get started. Problem number 1. Expand f of z is equal to 1 by z square minus 3z plus 2 in the region A, modulus of z less than 1, B, modulus of z greater than 2. First, let me solve problem number 1a. So, solution to problem number 1a. So, here given f of z is equal to 1 by z square minus 3z plus 2. Now, let me factorize this denominator. So, after factorizing this term, that means z square minus 3z plus 2 can be written as z minus 1 into z minus 2. So, finally, this term can be written as 1 by z minus 1 into z minus 2. Next, let me resolve this term into partial fraction by using partial fraction method. So, after applying partial fraction method, this term can be written as minus 1 by z minus 1 plus 1 by z minus 2. Here I am assuming that you have very good command on partial fraction method, but still if you have forgotten, let me show you how I get these two terms from this term. So, this term can be written as 1 divided by z minus 1 into z minus 2 as a divided by z minus 1 plus b divided by z minus 2. Here our main target is to find out the values of a and b. So, first what we need to do is that we have to multiply both sides by z minus 1 into z minus 2. So, after multiplying we will get the left hand side as 1 and right hand side will become a into z minus 2 plus b into z minus 1. Here we have seen that we have to find out two unknowns, that means a and b from one equation, which is impossible, but we will apply one trick. The trick is, while finding the value of a, we have to make this term equal to 0. Again, while finding the value of b, we have to make this term equal to 0. First, let me find out the value of a by making this term equal to 0. Here we have seen that when z equal to 1, then this term will become 0. So, when z equal to 1, then this term will become 0 and the value of a will be minus 1, because 1 minus 2 value is minus 1. So, when z equal to 1, then the value of a will be minus 1. Next, let me find out the value of b by making this term equal to 0. So, here we have seen that when z equal to 2, then this term will become 0. So, when z equal to 2, then this term will become 0 and b will be 2 minus 1, 1. So, 1. So, finally, this term can be written as 1 by z minus 1 into z minus 2 is equal to a. A value is minus 1. Minus 1 divided by z minus 1 plus b means 1. 1 divided by z minus 2. Okay? So, finally, we get f of z is equal to minus 1 by z minus 1 plus 1 by z minus 2. Next, our target is we have to expand this function f of z in the region modulus of z less than 1. So, here what we need to do is that we have to convert this term and this term to this form, so that we can apply binomial theorem. Here the first term has to be 1 and the second term, that means x, has to be less than 1. So, first let us multiply minus 1 to this denominator. after multiplying minus 1 to this denominator, we will get 1 by 1 minus z, which is in the form 1 minus x whole to the power minus 1, because the first term is 1 and the second term z according to question less than 1. Plus, again for getting this form, we have to take minus 2 common from the denominator of the second term. So, after taking minus 2 common from the denominator, we will get 1 by minus 2 into 1 minus z by 2. Now, let us check whether these two conditions are satisfied or not. So, here the first term is 1, that means the first condition is satisfied. Here the second term is z by 2 and this value has to be less than 1. Since according to question modulus of z is less than 1, so therefore less than 1 divided by 2. So, obviously the second term is less than 1. So, therefore we can apply binomial theorem. So, these two terms can be written as 1 minus z whole to the power minus 1 minus 1 by 2 into 1 minus z by 2 whole to the power minus 1. So, finally we get f of z is equal to, first let us apply binomial theorem to this term 1 minus z whole to the power minus 1. So, 1 minus z whole to the power minus 1 is 1 plus z plus z square plus z cube plus dot dot dot. Again, let us apply binomial theorem to this term, that means 1 minus z by 2 whole to the power minus 1. So, finally we will get 1 by 2 into 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube plus dot dot dot. Finally, let us add same power terms of this series and this series. So, if we add this term and this term, we will get 1 minus half equal to half. Again, if we add this term and this term, we will get 1 minus 1 by 4, that means 3 by 4 into z. Again, if we add this term and this term, we will get 1 minus 1 by 8, that means 7 by 8 z square. Again, if we add this term and this term, we will get 1 minus 1 by 16. So, 15 by 16 into z cube plus dot dot dot, which is the required Taylor series expansion, which is the required Taylor series expansion. Series expansion. Next, let me solve the second part of this problem. According to this problem, we have to expand f of z equal to 1 by z square minus 3z plus 2 into region modulus of z greater than 2. Students, for this problem up to this step, the procedure is same. However, we cannot write first term in this way and the second term in this way, because if we write, then this condition is violated, because according to this problem the value of modulus of z greater than 2. So, for this case the second term becomes greater than 1. So, we cannot write in this way. Here what we need to do is that we have to take z common from the denominator of first term and second term. So, finally we will get minus 1 by z into 1 minus 1 by z plus 1 by z into 1 minus 2 by z. So, here we have seen that both these conditions are satisfied. For this term, first term is 1 and the second term is less than 1, because value of modulus of z greater than 2. Again, for this term, the value of first term is 1 and the second term is less than 1, because 2 divided by greater than 2 always less than 1. So finally we get f of z is equal to minus 1 by z into 1 minus 1 by z whole to the power minus 1 plus 1 by z into 1 minus 2 by z whole to the power minus 1. Now let us expand this term and this term by using binomial theorem. So finally we will get minus 1 by z into 1 plus 1 by z plus 1 by z whole square plus 1 by z whole cube plus dot 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 plus 1 by z into, again let us expand this term by using binomial theorem. So finally we will get 1 plus 2 by z plus 2 by z whole square plus 2 by z whole cube plus dot dot dot. Finally let us add the same power terms of this series and this series. So if we add this term and this term, we will get 0 value, because minus 1 by z plus 1 by z is 0. Again if we add this term and this term, we will get minus 1 by z square plus 2 by z square. So value is 1 by z square. Again if we add this term and this term, we will get minus 1 by z cube plus 4 by z cube. So 3 divided by z cube. Again if we add this term and this term, we will get 7 divided by z to the power 4 plus dot dot dot. So finally we get z to the power minus 2 plus 3 into z to the power minus 3 plus 7 into z to the power minus 4 plus dot dot dot, which is the required Taylor series expansion. Next let us learn how to expand inverse trigonometric functions and logarithmic functions via Taylor series. Students, for expanding an inverse trigonometric function or logarithmic function via Taylor series, we have to follow 3 steps. In step number 1, we have to take the derivative of the function. That means we have to find out the value of f prime z. In step number 2, we have to expand the derivative of the function. That means f prime z about the mentioned point. And in last step, we have to take the integration with respect to z on both the sides. Now let us solve some numerical problems to understand this theory part. Problem number 1. Expand f of z equal to tan inverse z about z equal to 0 for a. Modulus of z less than 1, b. Modulus of z greater than 1. Here the inverse trigonometric function is tan inverse z. Solution. Solution to problem number 1a. Given f of z is equal to tan inverse z. Next we have to find out f prime z. So f prime z will be the derivative of tan inverse z is 1 by 1 plus z square, which can be written as 1 plus z square whole to the power minus 1. Now let us move to step number 2. Here the first term is 1 and second term is less than 1, because according to problem number 1a, modulus of z is less than 1. So obviously z square value is less than 1. So we can apply binomial theorem to expand this term about z equal to 0. So let us expand this term. f prime z is equal to 1 minus z square plus z square whole square minus z square whole cube plus dot dot dot. So, after simplifying, we can write f prime z is equal to 1 minus z square plus z to the power 4 minus z to the power 6 plus dot dot dot. So, integrating equation 1 with respect to z, both sides we get integrating equation 1 with respect to z on both sides we get integration f prime z dz is equal to integration 1 minus z square plus z to the power 4 minus z to the power 6 plus dot 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 into dz. We know f prime z is 1 by 1 plus z square. So, integration 1 by 1 plus z square into dz is equal to integration dz. So, value is z. If we take integration of this second term, we will get z cube by 3. After doing integration of this term, we will get z to the power 5 by 5. Again, after doing integration of this term, we will get z to the power 7 by 7 plus dot dot dot. So, finally, we can write, we know integration of 1 by 1 plus z square dz is tan inverse z. So, tan inverse z will be z minus z cube by 3 plus z to the power 5 by 5 minus z to the power 7 by 7 plus dot dot dot, which is the required Taylor series expansion, which is the required Taylor's series expansion. Now, let me solve problem number 1b. Students, for this problem up to this step the procedure is same. However, we cannot apply binomial theorem directly because for this problem the value of modulus of z is greater than 1. So, obviously, the value of z square is greater than 1. So, here what we need to do is that we have to take common z square from these two terms. So, we can write f prime z is equal to z square into 1 plus 1 by z square whole to the power minus 1. So, this term can be written as f prime z is equal to 1 by z square into 1 plus 1 by z square whole to the power minus 1. So, here we have seen that the first term is 1. So, first condition is satisfied and second term is 1 by z square, which is less than 1 because modulus of z is greater than 1. So, obviously, 1 by z square value is less than 1. So, let us expand this term by using binomial theorem. So, we can write f prime z is equal to 1 by z square into 1 minus 1 by z square plus 1 by z square whole square minus 1 by z square whole cube plus dot dot dot. Now, let us multiply this term with this term. So, finally, we will get f prime z is equal to 1 by z square minus 1 by z to the power 4 plus 1 by z to the power 6 minus 1 by z to the power 8 plus dot dot. Suppose this is equation number 1. Now, integrating with respect to z on both sides of equation 1, we get integrating equation 1 with respect to z, we get integration f prime z dz is equal to integration 1 by z square minus 1 by z to the power 4 plus 1 by z to the power 6 minus 1 by z to the power 8 plus dot 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 into dz. So, after integrating left hand side, we will get tan inverse z, because f prime z is 1 by 1 plus z square. So, integrating 1 by 1 plus z square dz is tan inverse z. Again, integrating this first term, we will get minus 1 by z. Integrating this term, we will get plus 1 by 3 into 1 by z cube. Again, integrating this term, we will get minus 1 by 5 into 1 by z to the power 5. Again, integrating this term, we will get plus 1 by 7 into 1 by z to the power 7 plus or minus dot dot dot, which is the required Taylor series expansion, which is the required Taylor's series expansion. Now, let me solve problem number 2. According to this problem, we have to expand f of z is equal to log z minus 2 about z equal to 1 for modulus of z minus 1 greater than 1. Students, since we need to expand this function about z equal to 1, so the expansion should contain the powers of z minus 1 only. First, let me write this point. The expansion should contain the powers of z minus 1 only. Okay? So, given f of z is equal to log z minus 2. Now, let us find out f prime z. So, f prime z is equal to, we know the derivative of log z minus 2 is 1 by z minus 2. Now, let me rearrange this denominator so that we will obtain a series as a power of z minus 1 only. So, we will get 1 by z minus 1 minus 1. Now, let us take common z minus 1 from this denominator. So, finally, we will get f prime z is equal to 1 by z minus 1 into 1 minus 1 by z minus 1. So, we can write f prime z is equal to 1 by z minus 1 into 1 minus 1 by z minus 1 whole to the power minus 1. Here the first term is 1 and the second term is less than 1, because according to this problem modulus of z minus 1 is greater than 1. So, obviously 1 by z minus 1 is less than 1. So, we can apply binomial theorem to expand this term. So, let us apply binomial theorem. So, finally we will get f prime z is equal to 1 by z minus 1 into 1 plus 1 by z minus 1 plus 1 by z minus 1 whole square plus 1 by z minus 1 whole cube plus dot dot dot. Now, let us multiply this term with this term. So, finally we will get f prime z is equal to 1 by z minus 1 plus 1 by z minus 1 whole square plus 1 by z minus 1 whole cube plus 1 by z minus 1 whole to the power 4 plus dot dot dot. Suppose this is equation number 1. Now, integrating equation 1 with respect to z on both sides, we get integrating equation 1 with respect to z, we get. So, integration f prime z dz is equal to integration 1 by z minus 1 plus 1 by z minus 1 whole square plus 1 by z minus 1 whole cube plus dot 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 into dz. So, after integrating this left hand side, we will get log z minus 2. Again, integration of 1 by z minus 1 into dz is log z minus 1. Again, integrating second term, we will get minus 1 by z minus 1. Next, integrating this term, we will get minus 1 by 2 into 1 by z minus 1 whole square plus dot dot dot, which is the required Taylor series expansion, which is the required Taylor series expansion. This is all about today's video, and I hope that you have learned a lot from this video.